I am so sorry. Thank you so much for letting me know. That's not a good way to start things. So let me get back to what I was saying here. Today we're going to try to find the area of the top curve minus the bottom curve, the area between the two curves. And I'm just going to tell you how to do it. You're going to take the integral of the top curve minus the bottom curve, and you're going to go from A to B. That's the formula. Now, guys, we could spend a whole bunch of time talking about why or how and all those things. This is what you need to know. That's what you do. So if the area under the top curve from A to B was, let's say, 10, and the area under the bottom curve from A to B was, let's say, 2, then what would be the area of just the blue region? 8. You do 10 minus 2, you get 8. That's the big idea. Can you handle that? That's the big idea for today. That's all I've got. I'm just kidding. I'm going to do a couple of examples, but that's the big idea. Take the top curve minus the bottom curve. Now we could talk about splitting all these things up and talking about f of x sub I and all that good stuff. Basically what we're doing here is we're kind of drawing these little rectangles. Remember those Riemann sums we did on the warm-up? So we could do a very complicated Riemann sum there, right? The idea being, what if I wanted to find the length of that or the height of that rectangle? Well, you take the top thing minus the bottom function thing, right? That'd give you the total height of each of those rectangles. And then, of course, you would have to do that whole summation thing, and you do the limit as n goes to infinity. But there's the big idea. In fact, actually, this is the big idea for today. The area A of a region bounded by the curves f and g, starting at point A and going to point B, assuming that they're both continuous, and assuming that the f function is above the g function. That's what greater than or equal to means. That's it. By the way, would you guys agree that's not a super complicated concept for you to understand? So this is actually a really nice way to kind of ease back in right after spring break. You guys already know how to do FTC. So let's look at an example. Okay, I'm going to do this one by hand. In fact, I think I do the first two by hand, and then the last one I'm going to do with technology. So we're going to do them by hand. So if you want to work ahead, go ahead, but try to do it by hand. In other words, we're going to practice FTC. Find the area of the region bounded above by y equals e to the x, that's this curve here, and below by y equals x. And we're going to go from 0 to 1. In other words, we're trying to find the area of that light blue region right there. Now, guys, I've already told you the formula. If you want, you can just go ahead and do it. So let's do it. So I'm going to say that area is equal to, well, where are we going to start from? 0. Where are we going to end? 1. What's the top curve? Well, it's e to the x. What's the bottom curve? It's just x. By the way, if this is the AP exam and that was free response, you just earned yourself probably 2 points. By the way, that wasn't very hard, now was it? Notice, though, that I wrote calculus-y looking stuff. You know how I've all year long been, I guess I haven't done that too much this year because all the tests have been online. I guess the free response problem. Writing this down is super important on a free response question because they give you points for more than just the answer a lot of times. Just by writing this right here, they're like, oh, that student knows that this is an integral problem. And they know that we're starting at 0, we're ending at 1, and we're going to integrate the top function, there's the top one, and then the bottom one. So I maybe should make a note of that. So here's the top function, if you will, and then here's the bottom function. And now we just integrate. Okay, so we're going to use FTC now. What is the antiderivative of e to the x? It's e to the x. I hope you know that. What is the antiderivative of x?
X squared divided by 2.
You got it. X squared divided by 2. And then we just need to evaluate that from 0 to 1. Now, guys, I'm going to finish this guy out, but I hope you can appreciate this hasn't been that difficult, has it? So let's go ahead and finish it out. So this is going to be e to the 1 minus 1 squared over 2. That's the first part. You got to plug in the 1. Minus, and now what I got to plug in? The 0, right? So now I've got to do e to the 0 minus 0 squared over 2. That's the fundamental theorem of calculus, that most important thing that Mr. Allen's been talking about all year long. Well, not all year long, since we did chapter 4. Okay, so now keep in mind here, so let's do this. That's just e, right? 1 squared is, I think it's just 1, so that'd be minus 1/2. And then what's e to the 0? That's 1, so I got to put minus 1. And then what's 0 squared? Divided by 2. Okay, so what's negative 1/2 plus another negative 1? I think it's 3/2, isn't it? Now, guys, I don't know if you can appreciate this or not, but you realize that without calculus, this problem is completely impossible for you to do, right? Like there's no geometric formula that you could have used to do this. And I'm not saying that that's a pretty answer that makes you think, oh yeah, that's what I was thinking. But that is the answer, okay? By the way, would someone help me out with their calculator? Would you please take e minus 1.5 and tell me what that is as a decimal? I don't have it memorized. I'm guessing it to be about 1 point something.
1.21.
Give me one more decimal. Thank you. That's the area. Now, by the way, notice I wrote approximately equal to. And I would to 3 decimal places because that's what the AP exam requires us to do. By the way, first of all, if you wrote this answer on a no calculator part of the test, they know you're cheating and you're going to get in trouble. So that's not good. That's not what we were supposed to do here. I wanted to do it kind of the hard way, if you will, by hand, and it wasn't that bad. Comments or questions on the first example? What's the big idea? Top minus bottom and integrate, right? Integrate top minus bottom. Good? Any questions out here in virtual land? Please let me know if you got them. Hit me up in the, I know some of you said I can't hear it. Yeah, I appreciate that, Rowan. Okay, sorry guys, sometimes I turn my microphone off. Okay, let's move on. There's a blank slide. I guess I didn't need that. Okay, looky here. So you might say, well, Mr. Allen, if that's all we got to do today, I am ready. Well, it is, but I want you to look at this curve here. What's the problem? Why am I throwing this one in here, even though I haven't even mentioned what the curve is? Well, the reason I threw this one in here is you'll notice that this blue curve, which is this g of x and the f of x. Well, is the f of x on top over here? Yep. Is the g of x here below? Yep. But what happens here in the middle? They switched, didn't they? So listen carefully to what I'm getting ready to say. This particular problem, you're going to have to do how many integrals? 3. Because you got to always make sure you do the top minus the bottom, right? So I'm going to just get rid of this A and this B, and I guess I could leave that A. I'm now going to call that B. I'm now going to call this C. Ooh, can you guess what I'm going to call the next one? D. You're going to have to do 3 integrals. In other words, we're going to have to integrate. This is one way of doing it. You're going to integrate from 1 to b of f minus g dx. That's one way. That's going to give us S1. Then what are you going to do? You're going to integrate from b to c of g minus f, because guess what? They switched. And then what are you going to do? C to d. Again, going back now g minus, or f minus g. Now, if you want, you can do absolute value stuff as well. I have found that students, whenever I ask them to do anything with absolute value, they get completely confused on what to do with that. So there's another way. I'll let you guys decipher that as well. If you do the absolute value, you basically are getting rid of the negative stuff. What's going to happen here, if you just integrated from the A to the original B, this middle area turns out to be negative area, which is going to give you an incorrect result. Does that kind of make sense? Because you're going to take, by the way, can area ever technically be negative? No, not really, right? So you're going to have like, let's say this turns out to be 5, but then this here turns out to be -8, and then let's say that turned out to be 5 again. You get an answer for the total area being 2, which makes absolutely no sense, does it? You just said that 5 + 8 is negative or +2. That doesn't make sense. So here's one way to do it, or here's a different way to do it with absolute value symbols, okay? So there it is with the absolute value if you want to look at that. You can avoid the absolute values though by using, I'll just say this is Mr. Allen's trick, or it's not even a trick. So there's my way of doing it. A lot of times I'll just break them up into individual things and just make sure I got top minus bottom. I like top minus bottom, then I don't have to worry about absolute value. Okay, let's do one more problem. This one, there'll be no calculator as well. Can you guess why I put this one on here? Well, first of all, they switched, right? Guess what the other reason is I'm doing this one? Trig. You took pre-calculus last year. You probably did trig during the beginning of the whole pandemic thing. So my guess is some of you might be a little rusty on your trig stuff, right? Unfortunately, on the AP exam on May 4th, you do not get any reference sheets for trig. So I thought it might be a good idea to at least do one trig one, okay? Oh, by the way, this one actually works out pretty well. Can you guess what A is? It's 0, right? What's B? That's pi/4. What's C? Pi/2. You guys with me? Would you do me a favor? Would you set up the integral you think to find this area? That's the area of the blue and the orange together. I want both the blue and the orange areas. It says find the area of the regions bounded by the curves y equals sine of x, y equals cosine of x, x equals 0, and then x equals pi/2. Just set it up. You don't have to actually work it out. Okay, so I need some feedback here if you guys just here in the classroom. Do you guys want me to do the absolute value way or the Mr. Allen way? Mr. Allen way? Okay, fine. I'm just going to do the Mr. Allen way because that's honestly how I would do it. We can do the absolute value way if you're interested. We could talk about that later. But would you agree we're going to need to write 2 integrals, right? That's all we're going to do here. So I'm going to just say that the area is equal to the integral. Where am I going to start? Where am I going to at first? Pi/4, correct. What's the top function? The cosine function. What's the bottom function then? Duh. Gotta be the sine function. And then don't forget to write your dx. And technically, you should put parenthesis around there just to make sure that everyone realizes that the integrand is cosine x minus sine x. If you don't write the parentheses, though, I don't think it's a big deal. What will the second integral be? Well, it's going to start at pi/4 to pi/2. What's the top function now? The sine function minus the... By the way, if you kind of understand what I just wrote there, that's the lesson. It's not that complicated. It really isn't. And the beautiful thing is, like I try to say this at the beginning, it's tangible. You can draw a picture or graph it on your graphing calculator to give you some idea. Now, I'll just let you know, could they give you a problem like this on the AP exam without any picture? Of course they could. In fact, they definitely probably would. You got to be aware that, oh yeah, sine and cosine cross somewhere in the middle, right? And they're going to give you something that's relatively easy, right? But anyways, so let's go ahead. Can we just go ahead and do this? Let's go ahead and do it. We're going to do it without a calculator. What is the antiderivative of cosine? It is sine. The antiderivative of cosine is sine. What is the antiderivative of sine?
Negative.
So what's this going to become then? Plus cosine. Do you understand why that's a plus cosine there? And we need to evaluate this from where? 0 to pi over 4. Plus, now let's do the second one. Am I going too fast? What is the antiderivative of sine? That one is negative cosine, so I'll put a negative cosine. And what is the antiderivative of cosine? Sine. So this is going to be minus sine x, and we got to evaluate that from pi over 4 to pi over 2, right? Okay, so now notice I've got this negative here, so this is going to become, I'm going to write it this way. This is from 0 to pi over 4, or maybe I should have done that in the first place. Now I'm going to pull out that negative, is that okay? And I'm going to go ahead and leave them in the same order. But if I wanted to, could I switch them around? Like since that's addition, could I switch that sine and that cosine around? Now I want to, can anyone think of why that might be kind of, we're basically dealing with the same thing, right? There's a little bit of symmetry there. In fact, if you look at the blue and the orange, what do they look like? They look exactly the same, don't they? So essentially, once you get the first one, guess what you already have? But we're going to pretend that we don't know that, okay? So here we go. Now I'm still doing FTC. I've got to do the sine of pi over 4. In fact, I'm going to show all my work. Oops, I just wrote sine, sorry. Pi over 4 plus the cosine of pi over 4. That's, oh boy. Sorry, guys. Sometimes when I'm writing it freaks out here. Then I got to minus the sine of 0 plus the cosine of 0. And I'm going to do the next one in a different color here. Minus, now what I got to do? The cosine of pi over 2 plus the sine of pi over 2. Then what? Minus again. And then I got to do the cosine of pi over 4 plus the sine of pi over 4. Now, guys, I wrote a whole bunch of work there because I'm trying to not skip any steps so people are like, how did he do that? Now, I did that very quickly and I was talking. Did I make any mistakes or did I get everything written down okay? Does that look good? So remember, to do just this part, I do the pi over 4 part in the two pieces, right? But then I have to minus the bottom, the 0, 0, right? Then I had this minus here, so that minus is right there. And then I got to play this same game now over here. I think I wrote everything down okay. Guys, if you screw up your parentheses, you will screw up the answer. So be careful. All right, so here we go. Cross my fingers. Does anybody know what the sine of pi over 4 is? It is radical 2 over 2. Good. Does anybody know what the cosine of pi over 4 is? It is also radical 2 over 2. Minus, and I'm going to put parentheses now. In fact, here, let me put parentheses here as well. I guess I should have done that in green. Oh well. What's the sine of 0? 0. Cosine of 0? 1. I'm going to go to a different color here just to be different. Okay. Kind of harder question. What's the cosine of pi over 2? 0. Sine of pi over 2? Cosine of pi over 4, we already did that one. Net radical 2 over 2. Sine of pi over 4, radical 2. Oh boy. Over 2. I don't know what happened there. Sorry. Okay. All right, you guys ready to get the final answer? Let's see if we can get this. Let's do can we do the non-fraction parts first? What's this right here going to give us? -1, agreed? What's this going to give us? Another -1, which makes a total of -2. Do you guys agree with that? So I'm going to put -2. Now I'm going to do the fraction parts. Ready? What's radical 2 over radical 2 plus radical 2 over, radical 2 over 2 plus another radical 2 over 2? Radical 2. What's this radical 2 over 2 plus another radical 2 over 2? Oh, be careful. You see this negative? What's that make that? Positive. So what's a radical 2 plus a radical 2? 2 radical 2. That's the answer. Now, you may say, Mr. Allen, that seemed a lot harder than I thought it was going to be. Was any one step of that particularly difficult? Not really. But can you see how if you were sitting there without someone or Mr. Allen kind of reminding you, you might forget that, whatever the cosine of pi over 2 is 0. You might forget that. Could you see how that might happen? Anyways. Okay. Okay, we're doing great on time. I think we'll actually get done a little bit ahead. Remember, I tried to do 60 and then give you 30, right? Comments or questions on this problem? By the way, the biggest, most important thing is this. Did you understand the beginning part? That's the big idea. Everything else is just filling in the details. And by the way, if you wanted to, what you could have done is you could have taken this blue stuff here, get that answer, and just take it times 2, and you would have still got the same answer because there was some symmetry involved. All right, so how many examples have I done? 2, and I did both of them by hand, right? I have one more example. Can you guess how I'm going to do it? Calculator. So get your calculator ready. We're getting ready to use the calculator. Again, I guess I don't know. No, I'm just going to move on. I'm not going to rewrite all that stuff. Oh, I guess I should mention one thing. There are some examples where they're going to ask you to integrate along the y-axis. This can happen. It's not super common, but they might. You do the exact same way. We're used to going this way along the x-axis, right? But guys, I'm just telling you, if you have a function that's written in terms of y, it's the same thing. Now, when we're going on the x-axis, you go A is the one on the left and B is the one on the right, correct? If I'm going along the y-axis, guess what C is? The one on the bottom. Guess what D is? The one on the top. And I'm just telling you, in fact, let's go back to this last problem. If I go back to this last problem and I just said that, x is equal to the cosine of y, and here x is equal to the sine of y. By the way, those functions are now in terms of y. And here I said that this was y equals 0, and this was y equals pi over 2. Guess what the answer is to this now new problem I've created that goes along the y-axis? It's exactly the same thing. In fact, let me just tell you right now, you want to know the quick, easy way to get around those problems? Just change all the y's to x. And just do it like you would in terms of, and by the way, that's what your calculator does. So I'm just throwing that out. So in case you see something like this, which you might, hint, hint, just change everything in terms of x. If the area is whatever it is in terms of x, guess what it'll be in terms of y? Exactly the same. All right, let's do this last example and we'll call it a day. In fact, I'll just shut up. Would you go ahead and try to do it? And by the way, I need you to write an integral and then give me the answer. That's all you got to do on this one. Like here was my integral. That was, remember how I said that's really important? This is the most important work step. And then the answer. Those are the two most important things. So I need you to write the integral and the answer for this problem. And I'll give you a few minutes to do that. Actually, you know what? I might give you an exit, or not an exit slip, but I'm going to give you one more poll question. Again, this is a really tough poll question, particularly if you weren't paying attention. The point of the poll questions isn't to ask you hard questions. It's just to hopefully make sure you're still somewhat paying attention. In fact, let me read what the directions are for this one. It says, find the area of the region bounded by the curves. Y equals x over the square root of x squared plus 1, and y equals x to the fourth minus x. Okay, so let's go ahead and look at this one. What's the challenge on this one? You got to find out where A and B are, don't you? It didn't tell you. So the good news is I'm assuming you guys all know how to do that. Now what I've done here in my graphing calculator is, I hope I'm graphing this. So you see a little bit of a curve there and then a little bit of a curve there. So what's going on with this guy? Like it's hard to see everything. What do I need to do here? I think I might have, did I get a minus here? Is that a negative? Sure, that's a minus. Okay. So you can't even hardly see the curve here enough, can you? So what you can do is you can go to the table and look at the values here and see where we got. So it looks like, okay, it looks like A is at 0, 0, right? Now it looks like the first function is pretty small. It looks like they all stay kind of around 1. But then look at the second function. It gets really big, doesn't it? So I probably need to adjust my window here. So maybe I should go from, let's say, -1 to, what'd you guys use for your upper Y? 10? Okay, let's try that. Let's see what happens. So there's the first function. Okay, now I'm getting there. Let's go ahead and zoom in a little bit more. Let's go 4 there. Let's see what happens now. Okay, in fact, let's go in more, right? Now, guys, you might be saying, well, wait a minute, Mr. Allen, you mean I got to figure all this stuff out on my own? The answer is yes. They're not going to tell you how to use your calculator. You're going to have to figure out, okay, now can you see where the curves connect, where the bounded region is? A here is clearly 0, 0. And one way you could figure that out is just go to calculate and then go to intersect and then go from the left and to the right. I'm actually not going to find the 0, 0. Is that okay? The one I'm really interested in is this one over here. You guys remember how to use the intersect feature? So I'm going to go a little bit to the, oops. I'm going to go a little bit to the, sorry, a little bit to the left, hit enter. Then it says second curve. Again, I like to go a little bit past the point of intersection. Hit enter one more time. Looks like the intersection is at 1.1807757. Did you figure that out on your own? Hopefully you did. I'm actually going to write it here on my board because I don't want to forget that decimal. I know that A is 0 and B here is 1.1807757. I have to know that. By the way, which curve was on top? The first curve or the second curve? The first curve, right? Now I'm going to go back. Hopefully everyone understands what I've just done here. Okay, in fact, let me make sure I kind of finish this guy off here with some good instruction. So my curve kind of looks like this. And I'm going to do green. I'm going to call this one Y1, this is the green curve, right? And if I remember correctly, I think this green curve kind of did something like this, right? And I'm going to call that Y1 because that's what I put it in my calculator as. Does that make sense? Can you guess what I'm going to call the second curve? Y2. Man, you guys are sharp. I'm going to call this guy Y2. The Y2 curve kind of did this. Kind of went below the x-axis and then it kind of quickly went up like that, right? And we're trying to find what? This area here in the middle, which I'm going to try to highlight in yellow. Let's just do yellow. We're trying to find this area in here. Does that make sense? And we've just established, oops, doggone it. That was not what I wanted to do. Go back. There we go. Didn't want that to be so wide. So that's A. And then this point over here, that's B. A was at 0 and B was at 1.1807757. Agreed? Now you want to see the beautiful thing? Here's my work for this problem. If this was the calculator portion of the AP exam, I would simply write area equals the integral from A to B y sub 1 minus y sub 2 dx. That's all I have to write. I don't have to write any of the numbers again. I don't even have to write the functions again. Notice that I clearly wrote y1. I wrote that, and I wrote y2 as that, correct? I also right here noted that A was 0 and that B was that, correct? Is there any ambiguity right here? Nope. You do not have to rewrite them again. Now all you got to do is plug it in your calculator. So let's go ahead and do that together. Now, guys, I'm going to save this again. Keep. And let's go ahead and use our calculator to do that integral. I'm going to get out of this. And I'm going to say math 9. We're going to integrate from A, which is 0, to B, which was 1.18077757. Agreed? Can you guess what I'm going to write right here? Y1. I'm going to write Y1. Maybe. I'll try to write Y1. Do you guys remember the shortcut to get to Y1? If I hit alpha, I think it's trace, Y1. If you want to see what I just did there again or hear it again, I hit the green alpha, and then up here, trace, and then I selected Y1. And now I'm going to go to minus alpha, trace, and can you guess what I'm going to pick now? Y2. That's the shortcut. Now, can I just go ahead and hit enter right now? You still have to put dx, right? So I got to go over here and hit x. Oops. And there's your answer. And by the way, how many decimals do I need to write? So the answer is 0.785. 0.785. And that is that. I'm going to write that on here. And then I'm going to send out the exit slip, and I'll take questions if you have them. So the answer is 0. I think I said 785, didn't I? That's the area. Oh, shucks. Sorry, guys, it exited out of my exit slip thing. So, guys, I'd like everyone to do the exit slip, even if you were here in class, just to give me some feedback on how it went today. And then you've got the rest of the time to either work on homework, ask me questions. You fill in the blank. Let's copy. Okay, the exit slip is in the chat. Okay, good. Everyone got the second question right on the poll. Most of you got the first question right. Some of you didn't, but that's okay. I can. Here's the slip again in the chat, in case you didn't get it.